My presentation will be about the recent case study I did looking at the activity levels in London during the COVID-19 lockdown. As a brief introduction, I wanted to talk about my PhD and just to give a bit of context about the work that I have been doing so far. So my PhD has a retail focus, and I have been looking at how the retail areas have changed over the last couple of years. And the argument that I'm trying to make and prove in my PhD is that the traditional retail location models and the traditional data sources, which only look at the built infrastructure, are not fit for purpose in today's retailing environment. And instead, we should be looking at more dynamic data sources, which give us information about the human interaction and the human activities in the retail areas. Some of the data sources that I have been working with are retail unit data, which is provided to me by the local data company. This data, it's a huge database of almost all the retail units in the UK, and it gets updated on a yearly basis. And they're also doing an update now to see the situation after the lockdown. So it's a very good data source to see how the composition of retail units has changed in the UK. And I have been doing some work looking at how the changes in the composition are changing the human activity patterns in the retail areas. The second data source that I have worked a lot with is footfall data. I get this data from the project called Smart Street Sensor Project, which is a collaboration between the local data company and Consumer Data Research Center at the UCL. And at its peak, we had around 1,000 sensors installed at the retail units around the UK. At the moment, it's around 400 sensors. So those sensors are installed at the storefront, and they capture the signals coming from devices nearby to the sensor. This data then gets processed and cleaned in a way that the end result has the sensor ID and then the number of devices that have passed by this sensor in a 5-minute period. There have been previous studies using this data, have also done a bit of verification about how accurate those numbers are. And they have found that the numbers we are getting from those sensors are actually very close to the ground truth. However, the data is limited, and we only know what's happening in front of the sensors, but we don't know what's happening between the sensors. Which brings me to the last data source that I also used for this case study, which is collected using smartphone applications. So the user or the device owners to install the app, they also need to give a permission for the location data to be shared and stored. But once those permissions have been given, it's a very good data source to analyze the movement of those devices in retail areas and also between the retail areas. So far, I have been looking at those data sources in the context of retailing and in the context of retail areas. However, in March this year, when UK government announced the lockdown, most of the retail stores had to close. So there was no retail as we know it for a couple of weeks and months. So I decided to make use of those data sources that we have and shift the attention maybe away from the only retail areas and look at the urban areas in more general. Which brings me to the case study. In this case study, I looked at the activity levels in London and how they changed over the lockdown period. So the data I used is the same one I just described. It's collected using smartphone applications. Just to give you a bit of context, I only used Greater London data, so the data which covers the Greater London region, and only the data covering periods from January 2020 to July 2020. And this time period, the data has been collected from over 500,000 devices, And in total, those devices have created over 1.2 billion data points. But the use of those type of data sources always comes with the privacy and ethic concerns. So we took a couple of steps back and aggregated the data to 1 kilometer by 1 kilometer grid cells. So the subset of the data we used for this case study has information about every grid cell, and we know the number of active devices per hour in each of those grid cells in the period of January 2020 to July 2020. So in the first part of the case study, I just looked at how the retail areas changed, not the retail areas, but how the London area changed over the lockdown period. And I found that the activity levels were down by 50% already by the time the official lockdown was announced, which shows that those 50% were probably tourists or people commuting to London. And it also shows how dependent a metropolitan region like London is from people commuting to the city from outside on a daily basis. The lowest levels of activity were reached around the Easter holiday. And after that, it has been a very gradual rise of activity levels. And interestingly, the reopening of retail stores a month ago, and then the very highly anticipated reopening of pubs and restaurants a couple of weeks ago, didn't actually have a very strong impact on the general activity levels, and it didn't really boost the recovery of the Greater London area. As a side note, I also looked at other metropolitan regions, and Greater London seems to be very much an outlier in UK context. And other metropolitan regions have mostly already recovered to the pre-lockdown levels. And the green lines on this graph show the levels at the same time last year. And if you look at, for example, Liverpool has recovered the activity levels from pre-lockdown level, and they have also already exceeded the activity levels which they had last year at the same time. So the recovery has been a lot faster outside of London. So coming back to the London case study, we were also interested in how different neighborhoods reacted to the lockdown. So I compared each of the grid cell to the activity levels of 2nd of March, which was the last normal Monday before the lockdown. And on 23rd of March, when the activity levels in general were down by 50%, there were still some areas which were a bit more active and where the lock had the effect a bit later. 13th of April was the kind of had the day with the lowest activities in London, where on the graph the dark red color shows the areas where the activity levels compared to the 2nd of March were down by 75%. And the third map shows the activity levels on last week on Monday, 13th of July, where we can see a very interesting dynamic between South and North London, where South London seems to be recovering a bit faster than North London. I also zoomed in and looked at the area around the UCL and Birkbeck campuses where the conference should have taken place. This area seems to be very, very empty. The activity levels last week were still down by 65%. So in the last part of the case study, we wanted to link this data that we have to different indicators and geodemographic classifications to see if we can find any explanation or if we can find any indicators which help us to predict how fast certain areas will recover. So we linked, using the population-weighted centroid, we linked each of the grid cell to, for example, the workplace classification and looked at the different dynamics there. So this graph shows the comparison between different workplace zones in London. and we found that the areas which are dominated by the residential services, which includes healthcare workers and construction workers, the decline of they didn't really have as much of the decline in activity levels as some other work-based zones, and the recovery has also been a bit faster. And in comparison, the city-focused work-based zones, which also includes the research and universities and the financial sector, they saw more of the decline, and they have also been slower to recover. And this can be explained by the fact that some jobs can be done from home, but for some other jobs, like for example construction work, people still need to travel. And having this information and being able to monitor the active levels in different work-based zones is a very good source of information for example, transport planners, who can then adjust the public transportation schedules accordingly, and to ensure that everybody who needs to travel for work can do so safely. I also looked at the different type of retail centers, and I found that the retail parks have been the fastest to recover, or have the fastest recovery rate. And in comparison, the leading comparison and leisure destinations, which tend to be in very central location, for example, Oxford Street in London is a good example of a leisure destination. They have been until now a bit slower to recover. However, although I said earlier that the opening of retail stores and the reopening of pubs and restaurants didn't really have a strong effect on the activity levels, they seem to have had a very strong impact on the leisure destinations. So it would be very interesting to see how this graph will look like in a couple of weeks' time, and maybe the kind of the central location and leisure destinations will kind of overtake the other type of retail centers. So that's all from me for now. I am updating those graphs on a weekly basis. I'm also sharing some of my work in Twitter, so please go and check this out, or just get in touch with me over the email or ask me any questions now. Thank you.
Okay, thank you, Terje. Any questions? Okay, can you tell us a bit about how you are handling or processing over 1 billion data points?
So the data is stored in the Google BigQuery by the company who provides us this data. So I use the Google BigQuery to do the pre-processing, and then export the aggregated data out from the BigQuery and do the rest of the processing in R.
Okay, and I can see that there are two maps in your work, right? And we can see a significant recovery of the human activity in Great London. And you show that the recovery trend for different function zones or different areas might be different. So do you plan to do some more spatial analysis to further understand those spatial effects underlying these changes or variations in space?
Yes.
Do you plan to
Yes,
do some?
Yes, yeah. I'm looking at, so the two examples I gave was the retail centers and the work-based zones. I have also been looking at the IMD index, for example, and the output area classification. However, the output area classification, which is residential-based classification, doesn't really seem to have a very strong effect on the differences. So yes, that's what I'm working on currently, and I'm also doing a bit more like analytical work, looking at the special regression models and trying to find different indicators which would help retailers or transport planners to predict which areas will recover faster, and maybe some areas will never return to the kind of pre-lockdown levels. Like, for example, Canary Wharf in London is a good example, which probably will take a very long time to get back to what it used to be. So yes, I'm looking at different indicators to kind of understand how fast different areas are recovering at the moment.
Okay, thank you. And another question from Huan Fa. Can you tell us the number of the APP users in your work, and can you talk about its representativeness of the population?
Mm-hmm. Yeah, that's a very good question. I mean, always with the mobile data, there's this question about how representative is this data for like older population, for example, who do not use this type of data. And I don't really have access to this part of the data. This data is just provided to us, but I know that in this time period of 2020, the data has been collected by more than 500 applications, and they are mostly transport apps and weather apps. Yeah.
Okay. Since we still have time, and I will read one more question from Sarah Weiss. She says, do you have any indicators or indications of how public appetite for delivery has shown up in this data? Can you distinguish between the couriers and the consumers? Some demographic things.
No, we don't have this information. We just know the location of the mobile phones, and the location is reported when the user is using one of the apps, but we don't know which app they are using. We just know that this device in this grid cell was active at this time. So we don't have this other information, but it is a very interesting point, and I hope to see research about this, how the deliveries have changed over the lockdown period.